Hey, boys and girls, ladies and gents, welcome to another episode on the Incredible Academics YouTube channel. Guys, this is just the continuation of part one of grade 12 proportional intercept theorem. Yeah, I had actually started with this question and then I got stuck. Why? Because there was a problem with the question. You know, this textbook, you guys, sometimes it just drives me nuts. Okay, because you see this question here. Only two lines are, said to be parallel, right? But from what I can see right now, there's no way you can be able to solve this diagram without having three lines parallel. But anyway, we'll talk about it later on. The thing that I want you guys to notice is that so far we've just been talking about the traditional proportional intercept theorem. Okay, traditional proportional intercept theorem. So in other words, AB over BC is equal to AG over GF, right? That's a traditional one. But I mean, sometimes the question comes a little bit different, right? So then your knowledge of this becomes very important. That BC, you can also go on to say BC. In fact, let's start with this one. AB, right? AB over AC, right? So AB over AC, right, is equal to, because I said AB, I'm also going to say AG on the other side, right? AG on the other side, divided by what? Remember, on the other side I said AC. So even this side I need to say AF, right? There's our AF. So this is still correct as well, right? This is still correct. And you can go on to say BC over AC, right? BC over AC, right? And obviously if you start with BC, even on the other side you have to start from G and then go to F. So GF over AF, as long as you maintain the order, you guys, that's the most important thing. So please look at the diagram carefully. So the length of AB is X, the length of BC is 2, and we've got DE and EF. So the length of EF is actually 3 units. Let me write this properly. 3 units, and DE, that's X plus 2. AD wasn't given to be parallel, but I'm telling you that you can try all day to solve the question. It's never going to work out if the line is not parallel. But now if all three lines are parallel and we construct our AF, so AF wasn't on this diagram, right? Initially we were just given a hint that we must construct the AF. Okay, so now that AF is here, what we can do is we can try and start solving. Okay, so I've done some substitution here, that X over 2 is equals to AG over GF, right? So obviously this is from there, AB over BC is equals to AG over GF. Okay, so now because this is from this triangle over there, now let's focus on the other triangle which is flipped. That's AFD. So in AFD, what I'm seeing is that AG over GF is equal to, hopefully you guys can't see, okay, AG over GF, right? AG over GF is equal to DE over EF. DE over EF. This is the situation. So it still holds. I know some people will be like, but why don't we start with the GF and then say over GA, guys? It's the same thing, You can literally you can literally flip these things around and say GF over AG is equals to EF over DE. Doesn't matter. It's the same thing as that. Okay, so let's focus on this because this is actually common. You can see that we've got AG over GF over there, right? AG over GF, which is equals to what? X over 2. So meaning that here we can simply put X over 2, AG over GF. And then what is DE, right? Let's go back and find what DE is and EF. DE is X plus 2, EF is 3. So X plus 2 divided by X plus 3. No, X plus 2 divided by 3, sorry, divided by 3. So we can do a cross multiplication as well for X. So 3X is going to be equal to 2X plus 4. And X is just 4 units. So we managed to solve for X. Okay. Now let's move on to slightly more interesting one. Here's the situation. You see with this diagram, we're just given the dots over there. They don't tell us that the two angles are actually equal. So I just looked at the problem and I was like, okay, if the two are not equal, then there's no way you can solve the problem. Okay, so you can just go through the diagram and yeah, take a look at it and see how we can start solving. So we asked to prove that this triangle here, right, ABD is an isosceles triangle. Okay, and we're given that this line and that line are parallel. And you guys know, whenever there's a Z between parallel lines, underline between parallel lines, not just a Z anywhere, a Z between parallel lines, then we're going to have alternating angles. So meaning that this angle here is equal to that angle here, but because this angle is already equal to that angle, that means the two are equal, right? So as always with geometry, you need to you need to be very explicit when writing down your answers. ABD is equal to BDE. The reason is alternating angles. Since there's parallel lines AB and DE. Okay. Right, and then we can go on to say since ADB is equal to BDE, and this is given, by the way, given, therefore ABD must be equal to ADB, right? So that's that. And therefore ABD, triangle ABD, is an isosceles triangle. Okay. Now, I mean, what's the implications of the triangle being isosceles, right? Simply means that this side is equal to that side. Okay, we cannot have these angles being equal without having the two sides being equal, right? So meaning that AD is 45 units. Okay, and the question goes on to say, please find DC. Okay, so how do you go about finding DC? We apply the proportional intercept theorem. Okay, DC over AD must be equal to EC over BE. So that's that. DC over AD must be equal to EC over BE, and this is line parallel to one side, line parallel to one side of triangle. Okay, so that's what we have over there. We're going to do our substitution. We don't know what DC is. DC is unknown, but our AD is 45. Okay, remember we've established that AD is 45 due to the fact that ABD, the triangle, is an isosceles triangle. Okay, so you can see that EC is 16 and EB is 32. So 16 over 32. All right, so now we can go right ahead and solve for DC. So DC over 45 is equal to 1 over 2. All right, and obviously now we can multiply both sides by 45, and DC is simply going to be 22,5. all right, you can punch that into your calculator and let's see if you're getting the same answer. And then there's another one which is slightly more interesting. Hopefully you guys can identify all the parallel lines. That's the most important thing when we're dealing with proportionality, you know, being able to identify the lines that are parallel. Okay, so you can see that there's this big triangle, the big one, QPR, and there's SV being parallel to QP, so you can apply our proportional intercept theorem over there. Then there's also another triangle, SPR, whereby SP is parallel to TV. Okay, literally your television. Right, so that's that. So we've got two triangles whereby we can apply proportional intercept theorem. I don't know if there's any other triangle that you guys can identify and I cannot, but anyway, yeah, let's carry on, you guys. So now what's going to happen is we are just gonna quickly find, so they're saying they want QR. So the entire length, you guys, is going to be a hell of a problem. So now let's plug in what's given. So they're saying PV is 24 millimeters. So where's PV? PV. So the whole of this is 24. Yes, that is 24. And VR is 22. So the whole of this is 22. What else are we given? ST is 12. Okay. Now you can see that in triangle PSR or PRS, we actually have the most information. Okay, we could go to PQR, but you can see that in PQR there's a lot of missing info. Okay, for instance, SR would be very crucial in us finding anything, if we were to operate in our QPR. So there's no QS, there's no SR. So I would suggest that we operate in PSR, okay, that triangle over there. And then we find our TR. Once we can get our TR, then we can use the fact that this ST is already given, then we sum it with the TR, then we're going to have our SR. Now with SR, VR, PV, you can definitely find your QS. Okay, so let's try, you guys, let's try. So looking at this triangle over here, you can see that TR over ST must be equal to VR over PV. All right, and now let's do the substitution. TR, that's what we're looking for. TR we don't have. ST is given as 12. VR as 22. And our PV is just 24. Okay, so multiply both sides of the equation by 12. TR is going to be equal to 22 divided by 2, which is just 11. Okay, you can confirm with your calculator. Hopefully we get the same answer. So now let's check, you guys. Now that we've got TR, remember SR is equal to ST plus TR. Literally SR is equal to ST plus TR. So meaning that we can just sum up the 12 and the 11 and we get our, our SR, which is going to be 23 units. Okay, and with SR now in the picture, we can actually find our QS, and once you've got your QS, you can just sum that with your SR, and then you're gonna have your QR, because remember, that's what we've been asked for initially. So let's then find our QS. So SR over QS, VR over PV. Okay, so SR over QS is equals to VR over Q over PV. Okay, over PV. SR over QS, VR over PV. So SR over QS, because there's the two lines being parallel. So SR over QS is equal to, we start from S, we went to R, so we're going to start from V and go to R. VR. Also here we start from Q, went to S, so we're going to start from P and go to V. Right? Voila. So now let's do the substitution. We know for a fact that QS is what we're looking for. In fact, we can then go right ahead and invert this. QS over SR is equal to PV, right? PV over what? Over VR. We are inverting simply because if QS is what we're looking for, we'd rather have it in the numerator so that it's easier for us to make it the subject of the formula. Do you understand? So if you flip one side of the equation, you must also flip the other side of the equation, then everything shall remain equal without any mathematical violation. Okay, so we don't know what QS is. Fine, we move right along. And then what is SR? SR, we said that is 23, remember? 23. And PV over VR. What is PV, you guys? PV is already given, actually. PV is already given. That's 24. And VR is 22. So 24 over 22. Okay, and obviously here we're gonna need a calculator, you guys. And the thing that disturbs me is that now it seems like we're going to get a decimal, and I don't like working with decimals. I just hope not. Alright, so that's 25 point to the nearest integer, let's just say it's 25. Okay, yeah, it's just 25, of which makes sense, plays along the lines of the lengths that we given, you know. It's not exactly an outlier. Okay, so now that we were QS and there's also SR, so you guys can see that definitely our QR is going to be the sum of QS and SR. So QR is going to be the sum of QS plus SR, and we know QS is 25, SR is 23, and our answer is simply going to be 48. All right, and that's that, you guys. Yeah, so we're done. I'm trying to show you guys this thing and my camera is refusing to move. So that's that. We're done. I'm out of here. Any questions, drop them in the comment section and I'll try to respond, you know, as quick as possible. Right. Peace out.